Hi everyone, it's Mrs. Wallace. I wanted to answer a couple of the questions from class today. So someone had a question about the production possibilities curve, so let's just define that. It's something that we did in Unit 1, and it's a great way to showcase opportunity costs, the way in which resources that are used to produce one good can't also be used then to produce something else at the same time. So if you want more of one good, you have to give up, some of another. So a PPC is a model that uses alternative ways that an economy can use its scarce resources. We're looking at, a few different concepts, especially opportunity costs, but also efficiency. We're looking at scarcity, the idea of trade-offs. There are some assumptions. We're looking at two goods that are being produced. Full employment of resources. We're assuming we can point out a few places on the model where there may not be full employment, but we're assuming any point on the PPC is using full employment of resources. Fixed resources, resources would be fixed. We can't expand them. Later on we'll relax that assumption. And we're going to assume technology is also fixed. Sometimes you're given a PPC in a table. Generally, you could be graphing this where on one axis you would have bikes and on another axis you would have computers. All of your resources in this case could make a total of 14 bikes or 8 computers, or some combination at B or C or D. For example, at point C, you could have 9 bikes and 4 computers with the same box of resources. Okay, so each point represents a specific combination of goods that can be produced given the set of resources. And if we graph this, you can see the two goods that this society can produce, maybe maxing out at 14 bicycles, or maxing out at a certain quantity of computers, or some combination in between. And this is the basic PPC. And we can kind of note that every single point from A, B, C, D, and E, every single one of those points is productively efficient, right? It is using all of the resources, and it is something that, B and C and D are equally as productively efficient. Each of these combinations is using all of society's resources, even though each point is offering society a different quantity. If we wanted to know, a different quantity of bikes and computers, if we did want to know what quantity society desires, that would be the allocatively efficient quantity. We would need to have data about society's marginal benefit and marginal costs for both bikes and computers. And of course, that can change over time. The marginal benefit of bikes can change, maybe as a result of climate change or something like that. Okay, but the basic model is here. We also can just use this in terms of opportunity costs. Every time I want to get one more computer, I have to give up a bike. And in this case, we don't have constant opportunity costs. I know I would have constant opportunity costs. If it was the case that every single time I wanted one more computer, I had to give up 2 bikes, another computer, 2 bikes, I would have constant opportunity costs, and it would be a linear curve. In this case, it is not. It is a bumped out or concave curve. So I know that this is going to be increasing opportunity costs. As I want progressively more and more and more computers, I have to give up progressively more and more and more bikes. And the same thing with when I want a new bike, or I want the society to be able to produce bikes, I have to give up progressively more and more computers. Okay, if I have a point on the PPC, we say it's efficient. If we have a point outside of this PPC, we simply say that's unattainable unless there is some way of shifting the PPC, and under the current conditions, we would say that's not the case. The other way you could have a society reach G would be to extend the PPC through trade. In other words, use some other societies better opportunity cost deal. You might be able to get more of a good if you trade, but generally you cannot achieve point G. It is unattainable. However, we could have a point that would be underneath the PPC. Any point underneath the PPC, we have an unemployment of resources. And even though we use unemployment specifically to talk about labor resources, in this case, unemployment of any resource, unemployment of land, unemployment of labor, unemployment of capital, robots that aren't being used. if we do not have full resources pumping, we are inefficient. Most societies are going to be existing, below their PPC. Keep in mind that here we have constant opportunity costs, and you would have a linear PPC. That would mean that resources are easily adaptable for producing either good. If in order to get one more pizza, I had to give up one calzone, and then to get another pizza, I had to give up one more calzone. To get another pizza, the third pizza, I had to give up one more calzone. That's telling me that my resources are kind of equipped to easily make pizza or calzone. So maybe I have sauce, cheese, a worker who knows how to make both of those goods, and an oven. Lots of equipment might be designed to either make pizza or calzones. If I do something where I'm going to say, okay, I'm going to make, a robot or pizza, now these are different kinds of resources. The same workers who make pizza are not going to be making robots. So the very first workers who make pizza are going to be those workers who are most equipped to make pizza, and they're going to be the cheapest resource, right? At a certain point in time, I'm going to have to give up more and more and more robots to convert resources that are not really equipped to provide pizza to be able to provide pizza, right? To take like a school or a marina and make it into a pizza factory, that's going to require some transitioning, okay? So resources that do not make products that are alike will create a bumped out PPC, and you're going to have the law of increasing opportunity costs as you move from A to B and B to C and C to D. In order to get more pizza, you have to give up progressively more and more and more robots. And in this data, in order to get, the first robot, I have to give up maybe one pizza. In order to get the second robot, I have to give up 2 pizzas. And to get the third robot, I have to give up 5 pizzas. So I progressively more and more pizza, and the curve, the PPC is going to get steeper, and that's increasing opportunity costs. As you produce more of any good, the opportunity costs will increase, okay? And remember, opportunity cost is the foregone production of that other good, okay? And why is this law of increasing opportunity costs happening? Because resources are not easily adaptable to producing both goods, okay? And we get this concave PPC. 4 assumptions we can revisit what happens if there is a change. In other words, we don't have resources fixed or technology fixed. What if we see an expansion of resources, right? More labor is moving in to a society. Perhaps there's more oil that's found, right? And that's a resource. What if technology gets enhanced and we have this like new ability to do something faster than we were before and use resources differently? These would be then shifters of the PPC. We can extend our PPC, which would increase our quantities of both goods. We could change the resource quantity. So remember, it was initially fixed, and we could actually increase the resources. Of course, they could also decrease. Change in technology, so enabling resources to be more productive, and then also change in trade. If you trade, whereas before you didn't, if you trade with a society that has a better opportunity cost ratio than your society does, you might be able to consume beyond the PPC. It doesn't really change the PPC for a particular society, but enables consumption beyond the PPC, okay? What happens if there's an increase in production? There goes our PPC. An increase, in population. That's because now we have more workers, more labor, we have an increase in PPC. What if there's technology improvement in pizza ovens, and this is a society making both pizza and robots? We know that we're going to see a bumped out, curve for pizzas, okay? And the same thing with the efficiencies, productive efficiency. Products are being produced in the least costly way. It's the same definition we have of productive efficiency elsewhere, but for the model of the PPC, we're not looking at price equals minimum ATC because we don't have that content on this graph. Just note any point that is actually on the PPC is productively efficient, and those points are equally productively efficient. Allocative efficiency, this is the products being produced are the ones most desired by society. The optimal point on the PPC would depend on the desires of society what would be society's optimal quantity. Say for vaccines for COVID, it depends on the context, right? At various points in the last 2 years, we've seen the marginal benefit curve for vaccines increase when we've had a need for many people, and when the cost was perhaps, when the benefit was much greater than the cost. At a certain point, could society have too many vaccines? Yes, right? So every single next vaccine, we're assessing what's the marginal benefit, what's the marginal cost. And that's information that we could use in a PPC, say for vaccines and say robots. We might know how much a society desires a particular good like vaccines, okay? I hope that this helps. I will see you in class tomorrow. We'll finish the free response questions and take some more practice tests, okay? Be well.